Hello everyone. This video is about solving the problems over falling bodies. Let's go ahead and start with the equations of motion. We know there are 5 equations of motion. Okay, let's go ahead and number those equations of motion. Let's call the first one here the average velocity equal distance over time, number 1. This equation just represents what's the average velocity equal to, which is initial velocity plus final over 2. Let's call the second equation here 2, that's acceleration equal to the final minus initial over time, and let's call this equation number 3 and this equation number 4. And as we learned before, whenever you are trying to solve a problem, you need to identify what you are giving, what is the unknown, and then look for the equation that has the unknown and also all the other variables in it are given to you. Now we need to be a little bit careful here when we solve problems over falling bodies. First of all, falling bodies is any object that's subjected to the acceleration of gravity, meaning the only acceleration acting on it is acceleration due to gravity. Whether this object is moving up or moving down, as long as it's influenced only by gravity, then it's a falling object. Okay, somebody might say, while you are throwing an object upward, there is other forces acting on the object, and that's correct. If you are holding an object and you are throwing it upward, at the moment you are throwing it upward, it's not a falling object problem because gravity is not the only factor. There is the force by your hand on the object. But as soon as the object leaves your hand, so the influence of your own force is not acting on the object anymore, this problem will turn into a free falling object problem. Okay, so don't confuse the act itself that caused the object to move forward with the action of the object as it's moving forward. While it's moving forward, the only influence is acceleration due to gravity, and hence the acceleration will be 9.8 meter per second or 9.8 meter per second squared downward. And usually we represent the direction by either positive or negative. And the standard way is to take upward to be positive, downward to be negative. And you can go the other way. You can take downward to be positive if you want and upward to be negative, but you have to be consistent. And therefore I recommend that you always follow the same standard, and I suggest that you take upward to be positive and downward to be negative. So this is an important point here. Another important point here is the concept of D. D here in the equations, equation 1, 3, represent displacement. Okay, and as we learned before, displacement is what? Displacement represents the final position minus the initial position. Okay, displacement is the final position, and here if we are talking about movement within the y-axis, within the vertical axis, since we are talking about falling objects, so we'll represent the position by y. So the displacement will be the final position in the y-axis minus the initial position. So keep that in mind when we solve problems over motion. Also, another important point here, always visualize the problem. Look at the initial status and the final status of the problem. That will determine your displacement, initial velocity, final velocity, and so on. So let's look at problem 1 here. A stone is shot straight upward with a speed of 24.4 meter per second. So we are given here the initial velocity. So V initial is 24.4 meter per second. And this is upward motion. So we have to include that is positive. So this is positive 24.4 meter per second from a tower and lands at the base of the tower with a speed of 44 meter per second. So this is V final. And again, it's very important, as I mentioned before, to visualize the problem. So here the object starts, if this is the tower, so you throw the object upward, it goes upward with this initial speed. Of course, whenever it moves upward, it will decelerate until it reaches final velocity of 0, then it will fall down. And here it's falling down to the base of the tower here. And the question is, what's the final velocity by which it will hit the base of the tower? Okay, now somebody might say, well, it will stop, it will become 0, and that's a wrong answer. V final here will not be 0 because we are asked to find the velocity at which it will land on the tower. before, meaning the final status here of the problem is before it comes to a stop, before it strikes the land. Of course, as a result, the ground will apply opposite force on it and it will cause it to stop. But the final status is before it strikes the land, just before, at the moment it's striking the ground. Okay, so we expect V final here to be negative or positive. Since the object will be moving downward, then V final should be negative. So V final will be at the moment it strike the ground here. And we are given the value of V final to be 44 meters per second. And is this positive or negative? Exactly, since V final is falling down, then it should be negative. Okay, what else are we given? Since it's a free falling object, then we know that A, or the acceleration of the object, will be equal to G, which is equivalent to 9.8 meters per second square. And is that positive or negative? Exactly, it's negative. Acceleration due to gravity is always downward. So as you see here, very important with vector quantities to include the sign. I expect you to include the sign for velocity, acceleration, and displacement D. Time, of course, is a scalar quantity, so time does not have a sign. Okay, so the question is, what is the time? Okay, that's what we're asked to find. Now, how about the displacement? Do we know the displacement of that object? Let's look at here. Now, remember, displacement is the final position, and here we have the final position, y final is at this point, minus the initial position. And the initial position is at this point. This is y initial. Okay. Now, if you take the y-axis, and this is the y-axis here, to start from this point, so this is 0, what will be the initial position? Since we are not given the height of the tower, then we don't know what is y initial. But we know that y final is 0, since it will hit the ground at the end. We are taking the ground to be our 0 position. Therefore, displacement here will be y final minus y initial, and y final is 0 minus y initial. Okay, but basically here in this question we are not asked to find the height of the tower. The question is, what's the time? How long will it take to hit the ground? So we'll be looking for an equation that has the time. This is our unknown, and those are equation number 1, 2, and 4. Also, at the same time, we are not given any information about the displacement, so this is not given. Therefore, we want an equation that does not have d in it. And this will limit our option to only one equation. That's equation number 2. That's the only equation that does not have displacement in it. Okay, let's go and work on the problem here. So we'll be using equation number 2 here to solve, and we are going to solve for t. So we are going to rearrange the equation to solve for t. Therefore, t will be equal to exactly v final minus v initial over the acceleration. So t will be equal to v final is given to be negative 44 meter per second, so negative 44, and this is meter per second, minus v initial, and v initial is what? V initial is positive 24.4, and always include the units, because the same way we are calculating numbers, we also calculate units. And this is all over the acceleration, which is negative 9.8 meter per second square. It will be negative 44 minus 24.4 divided by negative 9.8, and this will yield positive 6.98 seconds. Alright, so that's the answer here, and always make sure to circle the answer so that I know what you got. So it will take the stone around 6.98, around 7 seconds to hit the floor. I wonder what's the height of this tower, and this is maybe something you can work on it later. Okay, let's look at question number 2 here. In this problem, you are given Okay, before you solve this problem, make sure you write down what you are given. So please pause this video and go ahead and write down what you are given and what is the unknown. I assume you're already done with writing down what you are given. Okay, first thing, let's go and visualize what's going on here. The knot comes loose from a bolt on the bottom of an elevator as the elevator is moving up at 3 meters per second. So what would be the initial velocity of that knot? So we have here the elevator moving upward and the knot got loose. So while the elevator is moving upward at 3 meters per second, everything in it, including this knot, is moving with the same speed, 3 meters per second. So basically the knot got loose, it will, at the moment it's released, it's still moving with the same speed as the elevator, but since it's now a free falling object, it will be under the influence of acceleration due to gravity. So it will slow down, reach a zero velocity, then it will fall down and hit the ground. So it will move upward, reach zero velocity, then it will fall downward. Of course, this is vertical. Don't pay attention to my crooked drawing here. The question is, how far from the bottom of the shaft was the elevator when the knot fell off? So we need to find this displacement, this distance. So basically everything here will be our initial position. This is the initial I at the bottom of the shaft, and here is our final position. Okay, let's go ahead and write down what we are given. So the initial velocity is positive 3 meters per second. We are given the time to be 2 seconds, so we have time. What else we know? Since it's a free falling problem, then we know the acceleration is negative 9.8 meters per second square. We don't have any information about V final, so V final is not given. And the displacement is what we need to find. Now notice here displacement is always the final position minus the initial position. So here if we draw the y-axis as we did in the previous problem, this is the y-axis. If we take the ground, which will be the bottom of the shaft here, to be 0, then the initial position here will be the height. So basically we are trying to find the initial position. This will be the height of the elevator at the moment the bolt got loose. So this is y initial, and here y final will be 0. So this is y final. So basically the displacement here will be upward or downward. Displacement will be always the vector that connects the initial position to the final position. So this will be the displacement d from the initial position to the final position. So it will be 0 minus y initial, and that's what we need to find. We are trying to find the displacement, but we expect the displacement to be negative. Okay, since we have all the information now, let's go ahead and decide what equation should we use. Should we use equation number 1, 2, 3, or 4? Now we are not given V final, and we don't need to find it. We are asked to find the distance, the displacement. So we need an equation that does not have V final, and the only equation that does not have V final is equation 4. So we'll go ahead and apply equation number 4. The displacement is equal to the initial velocity times the time, which will be positive 3 meters per second, times the time, which is 2 seconds, plus 1/2 the acceleration, which is negative 9.8, and this is meter per second square, times t square, so times 2 second, and this is all square. So let's go ahead and simplify. So displacement will be equal to 3 times 2, that's 6, and second will cancel out with second. And we expect the units to cancel out to give us meter at the end. Plus 1/2 times 9.8 will give you 4.9 times 2 square, which is 4, so we have 4 times 4.9. And S here is second, that's not 5, this is S, second. So second square will cancel out with second square, and this will give you negative 19.6, and this is meter as well. So we have 6 meter minus 19.6 meter, and this will yield negative 13.6 meter. So negative 13.6 meter is the displacement from this point to this point. Okay, so to find y initial, which is the height would be 13.6 meter. So the elevator was 13.6 meter above the bottom of the shaft. Okay, in part B of the problem, it asks you how far above the bottom was the knot 0.250 second after it fell off. Okay, so if we go ahead and write down what we are given, notice that nothing changed with regard to the V initial. Still, V initial is positive 3 meter per second. The acceleration is still negative 9.8 meter per second square. The time has changed from 2 seconds to 0.50 seconds. And now the displacement is still y final minus y initial, and y final is still 0. So it's 0 minus. Now with regard to the displacement, the problem has changed. If this is the elevator and it's moving forward, of course, we know that the bolt will get loose. It will move at speed equal to 3 meter per second. Initially it will slow down, reach 0 speed, then it will fall down. Now we don't know where will be the knot after 0.250 seconds. So we don't know where its final position. If we take the bottom of the shaft to be 0, we know that the bolt at the moment is released, at the moment it leaves the elevator, it will be at 13.6 meter height. Okay, so we know this is the initial position, 13.6 meter height. We don't know what is the final position. So with regard to the displacement, which is y final minus y initial, we don't know y final. Y final is unknown, but we know that the initial position is 13.6 meter. Okay, so after we find the displacement, we can find the final position, y final. Notice here the displacement will be from this point to the final position. If the final position is here or here or here, whatever it is, or even here, it will be from the initial position to the final position, whether it's up here or up there. So in order to find y final, we have to add the displacement to y initial. Okay, this will enable you to find y final, which will be displacement plus 13.6, because y initial is 13.6. Okay, so again, since we are not given v final, the final velocity, we have to use equation number 4. Displacement is equal v initial times the time, and here v initial is still positive 3 meter per second. The time now is 0.25 second. This is second. Plus 1/2 AT square, so it's times 9, negative 9.8 meter per second square, times the time, which is 0.25 second all square. Okay, if you carry out the calculations, you get the answer to be 0.44 meter. Okay, so the 0.44 meter is basically, and it came out to be positive 0.44 meter, so it will be above the bottom of the elevator. It has moved from here up to there. Of course, at that time the elevator went upward further because the elevator is moving at constant speed. But for the knot, it went from 13.6 meter position up only 0.44 meters. So the 0.44 meter will be the displacement of the knot after 0.25 seconds from being released. It went up 0.44 meter after quarter of a second, after 0.25 seconds from being released. But the question here is about how far above the bottom of the shaft was the knot 0.25 meters. So we are asked to find this whole height from here to here. That's the question. And this will be the 13.6 meter, which is this distance, plus the displacement of the bolt, which is 0.44. So to find y final here, we have to add the displacement, which is 0.44, plus the 13.6. And this will yield around 14.04 meter, or 14.0 meter if we round it off to one decimal place. Okay, question number 3, a bottle dropped from a balloon reached the ground in 20 seconds. Determine the height of the balloon if it was at rest. In part A, there is V initial, there is V final, there is the time, there is the displacement, and there is the acceleration. In the case of free falling objects, the acceleration is 9.8 or negative 9.8 meter per second squared downward. Now here the bottle dropped from the bottom of the balloon, and we are told that it was at rest in the air when it was dropped. So V initial will be 1. Since it was at rest, then V initial is 0. How about V final? We don't have any information about V final in this question. How about the time? It tells us that the bottle dropped from the balloon reached the ground in 2 seconds, so the time is 2 seconds. How about the displacement? We are asked to determine the height. So actually, we know displacement is y final minus y initial. Do we have any information about y final and y initial? Again, if we imagine the problem here, this is the ground, this is the balloon, and this is the object that was dropped, the bottle that was dropped. So it went from here to there. Okay, if we draw the y-axis, it's the y-axis, and if we take the ground to be our 0, so this is the 0 of the y, the height of the balloon will be y initial or y final. This will be actually y initial. This is the initial position. Everything happened here. And the final position is when the bottle hit the ground. And when the bottle hits the ground, that's the final position. So 0 represents the final position, and the height of the balloon represents the initial position, and this is the displacement from upward to downward. So we expect D displacement to be negative, so this downward. So now if we go ahead and complete D final, it will be 0 minus y initial. So we are trying to find y initial, which will represent the height of the balloon at this moment. So again, the first question is, what is the equation we need to find? And again, if we are not given V final and we are not asked to find V final, the only equation that does not have V final is equation number 4. So we're going to implement the equation number 4, and also it has the distance that we need to find. It has the displacement that we need to find. So displacement is equal V initial times time. V initial is 0, so this part here is 0, since V initial is 0, plus 1/2 A, which is negative 9.8 meter per second square, times T squared. So it's time 2, and this is second square, this is second. Okay, if you carry out the calculation, you'll find that this displacement of that bottle will come to be 1960, and it's negative because we have negative 9.8 times 2 times 1/2. This is 1960 meters. And by the way, this is 20.0. I'm sorry, here this is 20.0. Okay, so 20 square will give you 400. 400 times negative 4.9 will yield negative 1960 meters. Therefore, y initial is positive 1960 meters. Because remember here, displacement will be equal to 0 minus y initial, meaning y initial will be negative the displacement, so it will be negative 1960, which is positive 1960 meters. So this will be the height of the balloon at the moment it's released, negative 1960 from the ground. Okay, let's look at part B. Part B has changed the velocity to 50 meters per second. So the balloon was moving upward with a speed of 50 meters per second. So the only thing changed here is the initial velocity, and of course this will change the height of the balloon at this moment. Everything else is the same. We still have 20 seconds for time. Acceleration is negative 9.8. V final is not given, and the displacement is still y final minus y initial, which will be 0 minus y initial. So we're going to use the same equation now. This displacement is equal V initial, which is positive 50 now, it's not 0 anymore, times the time, which is 20 seconds, plus 1/2 AT squared, so plus 1/2 times the acceleration, which is negative 9.8 meter per second square, times t square, which is 20 second all square. If you carry out the calculation, and you should be careful with the signs here, this will yield 1000 meter for this term here. Second will cancel out with second, plus negative 1960 meters. So the height of the balloon at this moment should be 960. The negative 960 is the displacement, and therefore y initial will be negative 960 meter, and this will give you positive 960 meter. And this will be the height of the balloon at this moment, in order for it to take 20 seconds to hit the ground if you throw the bottle upward with a speed of 50 meters per second. Okay, in question number 4, a baseball is thrown straight upward with a speed of 30 meters per second. How long will it rise? So basically we are given the initial speed here, V initial, which is 30, and this is positive since it's upward, meter per second. And the question is how long will it rise? So we're asked to find the time. Now how about acceleration? Of course acceleration is 9.8 meters per second square, since it's a free-falling problem. How about V final and distance? Are we given any information about the V final and distance? Let's look at the problem here. So you have a baseball thrown upward with a speed of 30 meters per second. As we know what will happen here, the baseball will start slowing down due to gravity. The acceleration due to gravity, G, is downward, so it will slow it down until what point? Until this baseball reaches zero velocity. Whenever it reaches zero velocity, it will stop. So it started with 30, slowing down up to zero, then after that it will fall back. But the question is how long will it take for it to rise? And this indicates that the final velocity will be zero, because that's when it will stop rising. So final velocity here is zero. And how about displacement? Is here, and we're not given any information about the displacement. We can take this position to be zero. So basically displacement, which is y final minus y initial, it will be basically y final. We don't know what will be y final. It will be somewhere here. Okay, so how can we solve for the time? So we need to look for an equation that has the time and it should not have displacement, because we are not given any information about the displacement. And this will be equation number 2. So we need to rearrange equation number 2 to solve for t. Therefore the time will be equal to v final minus v initial over the acceleration. I'm going to plug the values. V final is 0, v initial is positive 30 meter per second, and the acceleration is negative 9.8 meter per second square. If you carry out the calculation, this should yield 30.1 seconds. Okay, question B, how far will it rise? So we're asked to find the displacement here, and the rest of the information is still the same. So to solve for the displacement, you can use equation number 1, number 3, as well as number 4. Okay, I'll go ahead and solve this problem using equation number 4. It will be easier to solve it using equation number 1. Okay, 1, 3, or 4 will all work for this problem. So let's go and use equation number 3. V final square equal v initial square plus 2 times the acceleration times the displacement. Now v final square is 0. V initial square is the square of the positive 30 meter per second all square, plus 2 times a, which is negative 9.8, times d. And now if we solve for d, the positive 30, when you square it, will become 900, and that's meter square over second square. That's in the denominator, and this will be negative because we have to move it to the other side. It will become negative, divided by 2 times negative 9.8, which will be negative 19.6 meter per second square. Second square will cancel out, and you have meter square over meter, which will give you the answer in meter. And when you divide 900 by 19.6, of course negative will cancel out with the negative, you'll get 45.9 meters. So this is how high the space ball will rise. Okay, in question C, it asks you how long after it leaves the hand will it return to the starting point. Okay, here you might conclude that since it took 3.1 seconds from the previous problem to go up, and if we assume the air resistance is negligible, you can also predict that it will take 3.1 seconds to go down. But let's go ahead and prove it through the calculations. So the question is, how long after it leaves the hand will it return back to the starting point? So this is the starting position, throwing the ball upward. It will reach 0, then it will fall down and get back to your hand, upward and then downward. So what do we expect the time will be? Now notice here the change in the position is what? The displacement here is 0, since the starting point is the same as the ending point. Therefore displacement is 0. V initial is still 30, positive 30, and we are not given any information about V final. And we know the distance is negative 9.8 meter per second square. So we need to look for an equation that does not have V final, and this will be equation number 4. So if we go ahead and apply equation number 4, the distance, which is 0, equal to V initial times the time. So V initial is 30. We're applying equation number 4 here. 30 meter per second, it's positive, times the time, plus 1/2 times negative 9.8 meter per second square times t square. Okay, and you can see one of the possible answers is t equal to 0, and that's expected. That's the moment you throw the ball. Of course, in that case, the final and the initial position will be the same. So t equal to 0 is one of the answers, and we are not looking for this answer. The other answer is, by solving the problem, 0 equal to 30. If we cancel out the t, meter per second, plus the negative 4.9 times t, and the answer will be, of course, in that case you have to move that to the other side. It will be negative 30 divided by negative 4.9 this will yield 6.2 seconds. And this will be the correct answer. This is not. So here we proved that it takes 6.2 seconds, which is double the time it will take for it to reach its highest position. Okay, in part D of the question to ask you, when will a speed reach 16 meters per second? And you are told that there are two answers. Why are there two answers? Because again, if you imagine the problem, the ball was thrown upward with speed of 30 meters per second. So what will happen, it will move upward until it reaches speed of 0. So in the somewhere here in its way up, its speed will be positive 16 meters per second. And then after that, after it reaches 0 speed, it will fall down, and while it's falling down, also somewhere here its speed will be negative 16 meters per second. That's why we expect to find two answers. One of the answers will be in its way up, the other answer will be in its way down. Okay, so let's go and write down what we are given here. V initial is still positive 30 meters per second. Now V final, we have two possibilities. We have positive 16 meters per second and also negative 16, and this is meter per second. Okay, so we need to solve for both of them. And what else we have? Of course, the acceleration is negative 9.8, and we don't have any information about the displacement, and we are asked to find the time. So we need to look for an equation that does not have displacement, since displacement is not given. This equation has to have time. So the equation that fits this criteria is equation number 2. And we need to solve for t, so we rearrange equation number 2 here. T equal V final minus V initial over the acceleration. And we need to solve it for V final equal negative 16 and V final equal to positive 16. So we have two answers here. T equal to, and we'll take V final first to be positive 16, so it will be positive 16 minus V initial, which is positive 30, and this is all meters per second, over the acceleration, which is negative 9.8 meters per second square. You can see meter will cancel out with meter, and you have second over second square, which will be 1 over 1 over second. So the answer will be in second. And 16 minus 30 will yield negative 14 divided by negative 9.8. This will yield 1.43 seconds. And that's one of the answers. Now with the other one, t will be equal to negative 16, negative 30 over negative 9.8. And again, the units are as the previous one, so I'm not going to write the units just to save time. This will yield 4.69 seconds. Okay, so we got two answers here that represent the time. So it will take 1.43 seconds for it to reach 16 meters per second in its way upward. Then after that, it will take it 4.69 to reach the same speed, which is 16 meters per second, but now it's downward. Okay, question number 5. An angry student decides to throw an egg onto the head of his poor physics teacher. The student leans out of the school window 19.6 meters above the head of the approaching instructor. The question is to determine how many seconds before the teacher is directly under him that he will have to drop the egg. So let's imagine here the problem. This is the egg, and this is the head of the teacher, and the student is 19.6 meters above the head of the teacher. So if we take this position to be the 0 of the y-axis is moving, this is the y-axis, and this is y equal to 0, and this will be our y final, because This is the final position of the egg, and here it will be the initial position of the egg, which will be 19.6 meter. So this will be the displacement here. So we expect D to be negative, and this y final minus y initial, so it will be negative 19.6. So we have displacement D is negative 19.6 meters, and we have V initial, which is what? In part A, determine how many seconds before the teacher is directly under him that he will have to drop the egg in order to get the desired splat. So he will be dropping the egg from rest. That's what the question implies. It will be dropped from rest. And we don't have any information about V final, so V final is not given. And the question is how many seconds, so we're asked to find the time. And the acceleration will be what? The acceleration will be g, which is negative 9.8 meter per second square. Of course, it's downward. Okay, so we need to find an equation that has t, since t is the unknown. At the same time, it should not have the final velocity because we don't have the final velocity. And the only equation that does not have the final velocity is equation number what? Exactly, it's number 4. So if you go ahead and apply equation number 4, displacement, which will be negative 19.6 meters, is equal to V initial times time, and this part will be 0 since the initial velocity is 0, plus 1/2 AT squared. So plus 1/2 times 9.8 meter per second squared times t squared. So we'll be solving for t squared here. If you rearrange the equation and solve for t squared, this will yield 4 second square, this t squared. To find t, of course, we'll take the square root of 4, and the square root of 4 is negative 2 and positive 2. Of course, negative 2 is rejected because the time is a scalar quantity, so it cannot be negative. So the answer will be 2 seconds. Okay, in part B of the question, it asks you if the student decides to throw an egg downward. So instead of initial velocity equal to 0, the student is giving it an initial velocity that is more than 0, and it struck the teacher after 1.2 seconds instead of 2 seconds. What was the initial velocity of the egg? So we're asked to find the initial velocity, and all the other information are the same with the exception of the time. The time now is 1.2 seconds instead of 2 seconds. So let's go ahead and apply equation number 4 as well. Since we don't have V final, so we have to apply equation number 4. So again, the displacement is still 19.6 in the negative direction, equal V initial. Now V initial is no longer 0. V initial is our unknown times the t, which is 1.2, plus 1/2 AT squared. Okay, if we go ahead and solve for VI, this will yield second square will cancel out with second square. You get negative 7.06 meter. Now solving for V initial. Negative 12.54 meter divided by 1.2 seconds, and this will yield negative 10.54. Okay, so the student has to throw the ball with a speed of negative 10.54 meter per second downward in order to hit the head of the instructor or the head of the teacher in 1.2 seconds.